Greetings and welcome. I'm going to be reviewing example number 6 from chapter 5, lesson 5 on this video. Okay, so example 6 was an extension, if you remember, of example 5 of finding the real zeros of a polynomial function. So we have 3 steps. They're listed up here. And then if you remember me saying the difference between example 6 and example 5 is that we're going to use this step 3 multiple times. Okay, so step 1 is to use the degree of the polynomial to determine the number of real zeros. So the degree right here of our polynomial says that it is a degree 5, so it would have at most 5 real zeros. Step 2 is to use Descartes' rule of signs to determine the number of possible positive zeros and negative zeros. So to find the positive zeros, remember we use our original function, and we look for the sign change. So we have a sign change here from positive to negative. There's 1, negative to positive 2, 3, 4, 5. So remember Descartes' rule says that you could have 5, you could have 3, or you could have 1 positive real zero. Okay. Now, Descartes' rule also tells us how to find the possible negative real zeros. So in order to find the possible negative real zeros, we would substitute in negative x for all of x. So we've substituted in negative x for all of our x's, and now we're going to see how that changes our function. So remember, multiplying a negative to the 5th power, anything to the odd power, would remain a negative. Even power makes this a positive, positive times a negative, negative. This would remain a negative times 19, negative. A negative times a negative is a positive, positive times negative 37, negative 37. Positive 60 times negative x, negative 60x minus 36. Now we are going to look at the sign changes here. Negative, 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 negative. There are no sign changes. So that's going to tell us that we're going to have no negative real zeros. Okay. Step 3. Step 3 tells us that we want to look at our integer coefficients. We're going to identify those, and we are going to use the ratio of our constant, over the ratio of our over the leading coefficient. So in this case, we have 1 as a leading coefficient. So anything over 1 is going to simplify to that number. So in this case, we're just going to check all of the factors of 36. Now, why would we not check any negatives? Right, because we had no negative real zeros. This told us there was no sign changes, no negative real zeros. Sorry, I should have wrote no negative real zeros here. Okay, so these are our potential positive integers, or our potential positive real zeros. We don't have to simplify the ratios because the leading coefficient is 1, and we have no negative real zeros. All right, moving on. Step 3 tells us once we have our possible positive real zeros or our possible negative real zeros, we are going to start testing using synthetic division. So I'm going to go ahead and start with 1. Okay. So when I use 1 and I use synthetic division, okay, this is going to, sorry, I should have rewrote the function there, but the function right here, you list all of the coefficients. So 1, negative 7, 19, negative 37, 60, okay? So you're just going to get those. Okay, so we're going to list our leading coefficients, and we are going to test for 1, so we're going to divide by 1. This one comes right down. 1 times 1 is 1. We add these, so negative 7 plus 1, negative 6. 1 times negative 6, negative 6. Add these, 19 minus 6, 13. 13 times 1 over here is 13. We're going to add these, negative 24. 1 times negative 24, negative 24. Add these, 36. 1 times 36, 36, negative 36 plus 36, 0. So therefore, we have found a positive real 0. So we have a factor at x minus 1. Okay? Remember, because in order to get out 1, okay, we would want x minus 1. So this is a factor of our original function. So we're going to factor it out. And once we've factored it out, we can use our synthetic division to tell us our other function, our other factor. So now we're going to have x minus 1. We start with this leading coefficient, and we go down 1 degree from our original function. So our original function started with a degree of 5. So we're going to start with a degree of 4. So we're going to have 1x to the 4th. We just kind of follow this across, and we go down in descending order. So now negative 6x cubed plus 13x squared minus 24x plus 36. Okay, so this is where we stopped on example 5. We were done here, okay? But we're not done here. Remember, in example 5, we got down to a quadratic, and then that quadratic was our depressed equation, so we could factor from that quadratic, but we can't quite do that here. So we need to continue on with step 3. We're going to continue to check here. We're going to use the ratios here to use synthetic division to check for factors. So our factors are still going to be 1, 2, 3, 4, 6, 9, 12, 18, and 36. The factors of 36. Okay. All right, here we go. We're going to check 1. Okay, 1. Here are our coefficients for our new function. Okay, here, there. So 1, negative 6, 13, negative 24, 36. I'm going to list the 1. This 1 comes straight on down. 1 times 1 is 1. Add here, which would be negative 5. 1 times negative 5, negative 5. 13 plus negative 5, 8. 1 times 8, 8. Negative 24 plus 8, negative 16. 1 times negative 16, negative 16. Add, get 20. This is where our remainder is. So if you notice right here, 20 is not 0, okay? Because that's not 0, we're going to continue to check. So 1 does not work. Let's check 2, okay? Still using, oops, sorry, I just bumped the microphone. Still using those coefficients here. Now this time we're going to check with 2. So bring that 2 down. 2 times 1, 2. Add negative 4. Negative 4 times 2, negative 8. Add, we get 5. 2 times 5, 10. Add, negative 14. 2 times negative 14, negative 28. Oof, still, again, not a 0, so we're going to continue to check. I'm just going down the line, right? 1, 2, checked them, kind of cross those off, cross them off. Done with those, let's go on to 3. Whoa! Okay, let's check 3. Same thing, 1 comes down. 3 times 1 is 3. Add, negative 3. Multiply, negative 9. Add, 4 times 3, 12. Add, negative 12. Negative 12 times 3, negative 36. Hey, we have a 0. Yay! So 3 right here, that is going to be a real 0 of our function. So if 3 is a real 0 of our function, we can now find a factor of our function. Okay, we're going to have a factor of our function at x minus 3. Okay, I just copied these down because I wasn't sure how my pages were going to go, but they're going just fine. So sorry for the confusion. I just rewrote this here. Okay, so 3 is a 0, therefore x minus 3 is a factor. Okay, we have x minus 1. That's from way up here. We just kind of brought that one along. X minus 1. We're going to bring this down. Brought this. He kind of comes right on down to here. Okay. X minus 3 is also a factor. Okay. And now we're going to use these coefficients to rewrite another factor. Oh, there's my mom. So now we're going to go down 1 degree from where we were. So if you remember, this one started at degree 4. So if we're going down 1 degree, we're going to be going to the third. So 1x to the third, continue down. It will always continue down in descending order. Negative 3x squared. 4x minus 12. Okay, now this is our depressed equation. Okay, remember any real 0 of this, is a real 0 of our original function. Okay, so if you take a look, we have 1, 2, 3, 4 parts to it. So therefore we can go ahead and pair these up, and we can factor out. Okay, so pair these two, and we're going to factor. Okay, these two have an x squared in common. Take an x squared out of this, we're going to be left with x. Take an x squared out of here, minus 3. Take a 4 out of here, we're going to have x. Take a 4 out of the 12, we're going to have 3. Remember, we're going to combine our outside, so the 4 and the x squared. So we're going to x squared plus 4, and then we use 1 on the inside, so x minus 3 there. So, funny thing, take a look here. We have x minus 3 here, and we had x minus 3 up there. So that should tell us we're going to have a multiplicity of 2 at x minus 3. Okay. How about this one? This one's kind of unique. Where would its zeros be at? Has no real solution. Okay. Because we don't want imaginary numbers yet. We're looking for real numbers. Okay. Has no real solutions. 0 at 3. So 3 has a multiplicity of 2, right? X minus 3 has a multiplicity of 2, therefore the 0 of 3 has a multiplicity of 2. Our final factored form, okay? Our final factored form, we need to grab all of the factors we found. So that original time we have a factor at x minus 1. We also had x minus 3 squared. And then lastly, x squared plus 4. We are done.